How are you, class? I hope you are doing well. Today we are going to look at our topic again, circles, chords, and tangents. We're in lesson 3. Specifically today we are going to look at equal chords. Welcome. So I'm going to draw a circle, which I will use for the purpose of explaining this concept. So in this circle, I will introduce two equal chords, meaning that they are in this same circle and they are of equal length. So let me label my chords as A, B, C, and D. Then I introduce O at the center of that circle. So as you can see, I've come up with two triangles, triangle ABO and triangle COD. Now these triangles, because I've joined from the circumference of the circle, it means that AO is a radius, OB is also a radius, CO is also a radius, and even OD is a radius. Now, from what we know, if we have a triangle that has two equal sides, then that triangle, we call it an isosceles triangle. Therefore, the base angles of this isosceles triangle are going to be equal. Say this is theta. Now, if I look at the, if this is equal, if this AB is equal to CD, then it means that the base angle, because the radii are the same, then this is also going to be theta degrees. Now, the remaining angle that has been subtended at the center, we can call this 180 degrees minus 2 theta. At the same time, triangle COD, at the center here, we have 180 minus theta degrees. So we can make a conclusion that angles subtended by equal chords at the center are equal. As you can see, this is 180 minus 2 theta. This is 2 theta, sorry. And this is also 180 minus 2 theta. Therefore, a conclusion is that angles subtended by equal chords at the center of the circle are equal. Now, I want us to look at another concept. I'll draw another circle here. And I also have equal chords. Let me call this X, Y, and I call this L. I call this KL. Now, if I assume that we have also center O, I may join O to Y and O to L. Then I drop a perpendicular bisector to line XY. This means that from our previous topic, we learned that if you drop a perpendicular from the center, it forms an angle of 90 degrees. At the same time, if I drop a perpendicular bisector to line KL, it is going to form 90 degrees. So we want to look at these two triangles that are formed. That is, I can call this M, and then I call this point here N. So triangle MY, in triangle MYO, this MY equals to NL. At the same time, OL is a radius. It is also equal to OY. Now, OY is corresponding with OL. MN is also corresponding with NL. Therefore, because this is 90 degrees, then we can also extract that we have a right angle, we have the hypotenuse, and also we have the side. So therefore, triangle MYO and ONL are actually similar. Therefore, this distance ON equals to OM. Therefore, in my conclusion, I will say that the distance from the center, the distance from the center to the midpoint of xy is equal to the distance also from the center to the midpoint of line KL. So this is the conclusion we can get, that the distance subtended. Actually, if we have equal tangents, then it means that those, if we are not equal tangents, but if we have equal chords in the same circle, they are equidistant from the center, meaning that they have the same distance. That is, ON equals to OM. Thank you and have a nice time.